Hello students, in this video we are going to study about another compound of oxygen and hydrogen which is similar to water in structure and formula, but still it is highly different from water because water is essential for life, but this compound known as hydrogen peroxide is poisonous for life and it is highly flammable. So let's study about its chemical and physical properties. Hydrogen peroxide. Okay, so the first thing is structure of hydrogen peroxide actually, and the structure of hydrogen peroxide is like this. The formula is H2O2 and it is another hydride of oxygen. The first one was water, H2O, and this is H2O2. And unlike water, it is highly unstable. Water is highly stable, but hydrogen peroxide is highly unstable and it does not exist in nature as such actually. Okay, so what is the basic structure of H2O2 is like this. Actually, X-ray studies have shown that the structure is basically like this: oxygen, another oxygen, then a hydrogen, another hydrogen. This bond angle 94.8 degree. Okay, this bond angle 0. Okay, this bond length 0.95 angstrom, and if we talk about this bond angle, it is like 111.5 degree, and this bond length is again 1.47 angstrom. This was the one structure. Another possible structure is also like this: 2 oxygen, hydrogen, another hydrogen. This bond angle 90.2. This is 1.46 angstrom. This is 0.98 angstrom, and this 101.9 degree. So these are the two structure, 1 and B, 1A and B, and both of them are non-polar. In the crystal, the dihedral angle reduces to, okay, first of all, what is dihedral angle? Dihedral angle is like this: we have 2 oxygen, then we have 1 hydrogen, then another hydrogen. So what is the angle between these two is known as dihedral angle. Okay, so in crystal, the dihedral angle reduces to on account of hydrogen bonding. The 2 oxygen atoms are joined by single electron pair bond. The OO linkage is also called peroxide linkage. This is also called peroxide linkage actually. Okay, next is preparation of preparation of hydrogen peroxide. That means how hydrogen peroxide is prepared, and first is prepared from sodium peroxide, which is known as Mark's method. In this, calculated amount of sodium peroxide is gradually added to an ice cold solution of 20% sulfuric acid in a small lots with constant stirring, which results in formation of hydrogen peroxide according to this chemical reaction or equation. Okay, upon cooling, the crystals of sodium sulfate separate out and resulting solution contains about 30% of H2O2. The solution also contains some dissolved Na2SO4, but it does not interfere with the reaction of hydrogen peroxide. A pure sample of hydrogen peroxide may be prepared by distillation. Okay, it is 30% solution, so we use different methods, distillation, evaporation, to make it 100% solution by evaporating the water and other impurities. Okay, now there is another method of the formation of hydrogen peroxide, and this is done by from barium peroxide, and it is also known, it is a laboratory method used for preparation of hydrogen peroxide, and in this hydrogen peroxide is prepared from barium peroxide by this method. The first is by action of dilute sulfuric acid over barium peroxide, and the reaction is something like this: Ba, that is barium peroxide, when it is heated, it is acted upon by sulfuric acid, we get barium sulfate, and hydrogen peroxide and water molecule. So this is the first method for preparation of hydrogen peroxide from barium peroxide. Okay, now the white precipitate of BaSO4 produced in this reaction is removed by filtration, leaving behind a dilute solution of 5% hydrogen peroxide. In this method, anhydrous barium peroxide cannot be used since the precipitated BaSO4 forms a protective layer around the unreacted barium peroxide, thereby preventing its further reaction. So we need to use hydrated barium peroxide only, and we cannot use unhydrated barium peroxide for this method. Okay, next we can generate the hydrogen peroxide from barium peroxide by action of phosphoric acid, and the reaction would be something like this. We have BaO2 that reacts with H3PO4 to form Ba3PO4 whole twice, which settle down, and then we get hydrogen peroxide. Okay, so this is a method which can be used also, and in this we can use unhydrated barium peroxide very easily. This method has advantage that almost all the heavy metals like lead, etc., impurities present in BaO2 and which catalyze the decomposition of hydrogen peroxide are removed as insoluble phosphate. As a result, the resulting solution of H2O2 has good keeping properties. Okay, now physical properties of hydrogen peroxide. Pure hydrogen peroxide is colorless and syrupy liquid. It has odor like that of nitric acid. Its aqueous solution has bitter taste. It's soluble in water, alcohol and ether in all the proportions. Its density is 1.44 gram. The high density is due to association of its molecule by intermolecular hydrogen bonding. Its boiling point is 423 Kelvin at 670 mm pressure and 358 Kelvin at 68 mm pressure, and its melting point is 272 Kelvin. Now, chemical properties. The first is decomposition. The decomposition is that it is an unstable liquid readily decomposed on heating or on long straining to give water and dihydrogen. It is an example of disproportionation reaction. Okay, and it is suppressed by addition of glycerol, acetanilide or phosphoric acid. So what happens? We have H2O2, it is unstable. With the passage of time, if we have impurities like palladium and platinum, etc., it converts into H2O and O2. Okay, so if we want to balance this equation, we have to do this. So this is how hydrogen peroxide is unstable and it decomposes actually on standing. Next chemical property is acidic behavior. Actually, pure hydrogen peroxide is weak acid and it ionizes in water as H2O2 gives H positive and OH negative, that is hydro superoxide ion. Okay, and there is another way in which it can ionize in water. This further ionize to give peroxide ion and H positive. Okay, the acidic behavior can also be shown by reaction with sodium hydroxide. When it reacts with sodium hydroxide, it forms Na2O2, which is a salt, and gives 2 water molecules. Similarly, it reacts with sodium bicarbonate, hydrogen peroxide, to give Na2O3 plus water molecule and CO2. So this shows the basic acidic behavior of hydrogen peroxide. Okay, hydrogen peroxide has an interesting chemistry because of its ability to act as oxidizing agent as well as reducing agent both. So hydrogen peroxide acts as both oxidizing as well as reducing agent in acidic as well as basic medium. Okay, so let's have a look at the oxidizing behavior in acidic medium. What happens? Acidic medium, hydrogen peroxide reacts with the protons, takes 2 electrons to form water molecule. In basic medium, what would happen? That this hydrogen peroxide would take 2 electrons to form OH negative. So it can act as oxidizing agent in both acidic as well as basic medium, alkaline medium, and because of this oxidizing agent, it is used as bleaching. It has bleaching action and it is used as a bleaching agent. So what is done in bleaching? That coloring matter, we have, let's say we have a fabric on which there is some stain and we want to remove that stain. That stain is coloring matter. When that coloring matter comes in contact with hydrogen peroxide, we get colorless matter and we get water molecule. That means this coloring matter is oxidized actually, because of which it becomes now colorless matter. So it has bleaching properties also. Okay. Now it also undergoes some addition reaction. You can see there is an unsaturated hydrocarbon. When it is reacted with hydrogen peroxide, we have actually two parts, OH plus OH. One OH goes to this carbon, another OH goes to this carbon, and we get this compound glycerols. Now there is a question which asks about that what is bond angle, OOOH bond angle in hydrogen peroxide ion, and it is okay. It is bond angle is actually 94.8. So D is the correct option. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on get answer, and you will be answered within 24 to 48 hours by our experts. So students, we studied about structure, preparation and properties of hydrogen peroxide. So in this chapter we started with hydrogen, the elementary hydrogen. We studied about its properties and its position in periodic table, and now we know that how it is critical to assign the exact position for hydrogen in our periodic table. Then we moved to molecular hydrogen, the dihydrogen gas, its properties and preparation and also uses. Then we moved to two important compounds of hydrogen and oxygen, that is water and hydrogen peroxide. Let me finish with this in this chapter. For more videos on physics, chemistry, mathematics and biology, stay tuned with Ask IITians. Thank you.